Welcome back, everyone. So last time I mentioned something, but I want to reiterate this further. So, for example, in what can happen, you can say that, okay, what I'm going to do within a priority queue is that I'm going to take a vector and insert the smallest element, as a first entry. And so therefore, this is how I'm going to retain a sorted vector using this priority queue. Okay, so that is how internally you can use a dequeue or a vector uh, uh, using a priority queue, using a sequence, using a tree like adapter. And likewise in Java's priority queue, there is this list interface of queues, which is also used by this array queue. So you can see that this is an implementation of DQ within this priority queue algorithm. Likewise in Java, the stacks are basically inherited from vectors, which are in turn inherited from array list. Okay, so in some sense you can say that Java stack uses array list as baseline container. Okay, so let's talk about stack versus heap. So if you recall, in C++, we have 5 different types of memory locations in terms of architecture. So we have very low level machine level instructions, and then we have some portion allocated for initialized data, some portion allocated for uninitialized data. And so if you have static variables, some global variables, they come in here. And then we have stack memory, which is allocated for each function, each method separately. And then we have heap, which is allocated at runtime dynamically. In Java, the process is somewhat similar. So let's assume that we have a couple of classes. This will represent my stack memory, and this will represent my heap memory. And so remember, the stack is allocated for each function, for each method. Okay, so let's say that we come to this main function. At this line, remember, so in Java, we have 2 different types of data types. The first ones are primitive data types, and the other ones are reference data types. Primitive data types are stored in stack memory, and if any function has some primitive data type, it will be stored. It will be allocated memory within the space allocated to that particular function. And if it has some reference data type, the actual memory allocation will be done on heap. So let's say we start this main function, we have some primitive data type, we allocate this, this portion of memory within the stack of this main function. We allocate this 23 to, this specific portion of this memory. And then we have this second data type, which is a reference data type. So we just use a reference, which remember, a reference is just a simple integer. We will use that integer to to store, that integer will itself be stored within the memory allocated within the stack function of this main function, but the name actually will point to this John variable, which will which will be allocated memory in heap. Okay, so the actual variable, it can be John, it can be 100 characters, that will be allocated memory in heap. But you need, like, you need a reference. You need to you need to know the hash code, where will the hash code of this name will be saved. So the hash code will be saved in some sense, in this main function with using this name. Okay, so variable exists itself, but like, this is akin to saying that if you have pointers, if you have pointer to some string, you know that memory address will be stored over here, the string itself will be saved over here. Okay, now then we come to this portion create where we create a person and we assign null object. So imagine that, this person is, right now it's not, well, right now it says something, but at this point, at this line, this will be null. And there's this person variable over here that will point to this null object, okay? And then what happens is that, this null object will be replaced by something, whatever that thing is. Now that thing is basically another function or another constructor. So this build person, the compiler will allocate a separate stack memory on top of that function, on top of our main function. And within that function, what will happen is that this ID and this name will be copied to these two variables. Sorry, these two variables, these ID and this name string. And then what this means is that, within the space of this constructor, we have a couple of variables, this ID, which will contain a copy of this ID, which is 23. Okay, so this ID is basically a copy of this ID. And then this will contain, once again, the same reference, but that, this reference will point to the same John string that was pointed by the name variable in my main function. So we have a second local variable name, local in the sense that, it is local to this build person method. But once again, both both this name and this name, they are pointing to the same data allocated in heap. Now, then what happens is that we come to this line, and therein we have we will call something, and that something will return, something. Now I need to store that something. I'm calling this person variable, but this is not a person. This is what we call as anonymous object. Okay, so we need a placeholder to store whatever the output of this new person ID name is. Okay, so that is, this person object. But now what will happen is that the compiler will create, once again, this person is a constructor, it's a method. So compiler will create a separate space for this, this person method. Once again, this ID and this name will be copied to these two local variables, ID and name. Okay. So ID and name, once again, these are two local variables to this person constructor. But then in addition to that, once again, so string name, is pointing to the same object. But apart from these two local variables, ID and name, which are local to this person constructor, we also have, this ID and this name, which is binding to this person object itself. Okay, so we have a separate, so this will create a separate object. It will initialize the ID of that object to 23, and the ID of this name to whatever is pointed by that name. Okay, so now we have a fourth pointer to this name, to this John variable. Okay, but the interesting thing to note is that, this dot id, it exists in heap, because, this is something, this object, this person object exists in heap. Okay, now once we go out of the scope of this person constructor, what will happen is that the compiler will destroy this memory, which means that it will, destroy this ID and this name and, this object itself. But destroying this doesn't mean, this object is destroyed, because once it is destroyed, once we come over here, this placeholder of this build person, that will now point to the object, in heap. So even though we come out of this constructor, this local space is destroyed, but this object is still there. Okay, even though this ID and, this name. So you imagine that, this green line and this blue line are not there. Okay, and this ID, primitive data type is also not there, but this person object is there. Okay, and then, which is pointed by this person, and then once we come out of the scope of this build person and we return to this our main function, this is also destroyed. The build person stack memory is also destroyed, but once again, this means that this arrow and, this green arrow is destroyed. But now this person which exists in as an object, oh, sorry, as a as a hash code, or uh, as an integer reference to my main object, this person will now store whatever is being pointed by this person object. Okay, so now like now you don't have this connection and this connection, but you only have main connection that is pointing um, to this person, and within that person name is being pointed by John. And once we go out of the scope of this main, everything will be destroyed, including this ID name and this person. And once this person is destroyed, Java will automatically deallocate whatever is being allocated within the heap, because this person and this John, right, once the scope goes out of this main function, they are not being referenced, they are just hanging, like a dangling pointer. So Java will automatically um, destroy the unallocated reference types. So this is how uh, the step, the allocation and at stack and heap works. Once again, so the basic idea is that primitive data types are stored in stack, reference data types are stored in heap. Well, in Python we don't really have a stack. Everything exists in heaps, so everything happens at runtime. Really, you can literally say that variable a is 99999, like 100-digit integer. Okay, and what that means is that even for basic allocation of integer data types, that is being done at runtime. It's not that your integer is 4 or 8 bytes long. It really depends upon you. So Java Python allocates memory at runtime, so that is why it is very slow. Okay, so in the next lectures, in the next video, we are going to see a class hierarchy of different collections that we have in Java.